Okay, well, good afternoon, everyone. This is Andrew. Today I'm running through the problem of the week, run length encoding run. Okay, hopefully you guys know the drill by now because it's been like a year. I'll read through the problem and then we'll go through some code. Forrest lives in a prehistoric era of dial-up internet. Unlike the fast streaming of today's broadband era, dial-up connections are only capable of transmitting small amounts of text data at reasonable speeds. Forrest has noticed that his communications typically include repeated characters and has designed a simple compression scheme based on repeated information. Text data is encoded for transmission, possibly resulting in a much shorter data string, and decoded after transmission to reveal the original data. The compression scheme is rather simple. When encoding a text string, repeated consecutive characters are replaced by a single instance of that character and the number of occurrences of that character, the character's run length. Decoding an encoded string results in the original string by repeating each character the number of times encoded by the run length. Forrest calls this encoding scheme run length encoding. We don't actually think he was the first person to invent it, but we haven't mentioned that to him. For example, the string hello is encoded as H3E2L301, and decoding that same thing results in the original string. Forrest has hired you to write an implementation for his run length encoding algorithm. Input consists of a single line of text, which starts with E or D, standing for encode and decode, followed by a single space and then the message. Okay. And then you output whatever it wants you to encode. So this isn't too complicated of a encoding scheme, but I think basically what they want you to do here is look at consecutive characters and then replace it with one character and one number. Let's go ahead and look at the code. All right, here's what I've written. I have two functions here for encoding and decoding, but actually we'll start down here where you actually take in the input. So first we take an input, setup, and string. I use the split function so I can grab E and the string out. I check the characters here, and then I run encode and decode depending on what character it is. So for encode, this one is the longer function, but really neither of these are too complicated. I turn the string into a list. I create a list for the output, and I set up a count variable. And this count variable is basically just here to return the number of occurrences of the letter. So I run through this range where I go from 0 to the length of the string minus 1. And then I say, if this character is equal to the next character, this is why I have the -1. Then we increment the count by 1, and we go to the next iteration. Otherwise, you go ahead and you append the character to this list, and you append the count, you reset the count to 1. Really, the continue here wasn't necessary. I just thought it was, well, I mainly put it here for my own comprehension in checking the program, but really it's not necessary because the for loop ends like right here, and you wouldn't get to the else anyways. And then once you get out of the for loop, I append the last letter, and then I just give it a 1 because you know that this is going to be 1 if it's the last letter. So here you might think, Andrew, you're kind of leaving it open. What if it's, something like 2 exclamation marks? This would be caught anyways by the string character here, and you would be fine. So, for example, we can look at it here. Oh yeah, I copied the wrong thing. Okay, there. Yeah, see, so for example, it works fine. All right, next, moving on to decode. This one's a lot simpler. Again, I translate it into a list, but here I use a string, and here I'm using a feature in Python called a string multiplication, where I basically I take the string and I multiply by number, and that gives me the number of occurrences. So I set up a for loop here to run through the string, and I'm skipping every other character because I know that every other character is a number. And then here I just add the character and I multiply it by its number of occurrences to the decoded string, and then I print out the decoded string. Now notice here I just have return. It'll just return null because I don't need it to return anything. And then the problem will be fine because I'm printing out what I need to print out. So again, we can run it here and it works fine. All right, so that's the problem of the week. Have a great weekend.